The big thing to point out, it's really important here, is not all sequences are convergent. Okay, let's look at a couple of examples. Some of them, let's look at the limit as n approaches infinity of -1 raised to the n. So if you think about the values that -1 raised to the n takes, remember n has to be a natural number. So I'm looking at -1 to the 0, which will be 1. Then I'm looking at -1 to the 1, which will be -1. Then I'm looking at -1 squared, which will be 1. Then I'm looking at -1 cubed, which will be -1. And this oscillates forever. It doesn't have a definite value that it's trending to. Another example of something that's not convergent is if you could look at something that just blows up and goes to infinity as n goes to infinity. An example of this would be, let's look at a sub n is equal to 2 to the n. If you look at the limit as n approaches infinity of a sub n, here you have 2 to the 0, which is 1, 2 to the 1, which is 2. What's happening is this is just going to get bigger and bigger. This is increasing with no bound. And so some people would write, and it's common that you'll see this, the limit as n approaches infinity of a sub n is equal to positive infinity. But we would still say that this diverges because it's not heading towards what we would consider a number. Infinity is a concept in our world, not a number. So even though there is a definite trend, it doesn't have a specific limit. And the final thing that you might see is what's called chaos. So in the previous two examples, we saw something that we could describe really easily. I know what's going to happen here, and that allows me to predict that the long-term behavior is not a specific number. So an example of chaos would be, what if you looked at a recursive sequence that was defined with x sub 0 is equal to 0.5, and then x sub n plus 1 is equal to 3.897 x sub n? Okay, another possibility for a sequence that is not convergent is it can be what's called chaotic. So to give an example of this, I'm going to define a sequence recursively through a recurrence relation that gives the initial value and that gives the previous, or the next term in terms of the previous value. So I'm going to have x sub 0 is equal to 0.5, and x sub n plus 1 is equal to 3.9 x sub n times 1 minus x sub n. I'm going to use Wolfram alpha to generate some terms here. So if I get started and I say 3.9 times 0.5 times 1 minus 0.5, that is 0.97. And maybe I'm tempted to think that that's going to go somewhere. Let's plug in 0.97 to the formula. But that drops really dramatically to 0.11349. And then if I look at x sub 3, and just repeat this process to generate all the values. And do not round. Keep all the decimal places that you have. Then suddenly it jumps back up to 0.392379077761. And what you see if you continue this is that there's no definite pattern. It's bounded. The sequence stays between 0 and 1. So I encourage you to continue to experiment with this. Perhaps you can use a spreadsheet, but this never settles into a definite pattern. And there's no value that it's tending towards, so this does not converge. And here we would say the limit as n approaches infinity of a sub n does not exist.